In the last lesson we went through and figured out how to do some basic commands to make some designs to have the different objects cut out on the CNC plasma cutter. So here's some examples of 3 different designs. So there's a couple different things that we need to add to this, and in this lesson we're going to talk about P-lines, the kerf, how it's actually going to be cut out on the CNC plasma cutter, and talk about small little movements also. So the first thing is, let's talk about kerf first. So let's look at this object right here. So the idea here is, and it's kind of hard to see this, and I can use my hatch to show what parts are going to be cut out and what parts are going to be left. So whenever you send this file to the plasma cutter, it automatically figures out what is the outline of the object and what parts are going to be cut out from the inside. To help you be able to see that, we can use our hatch command like we did before, and I'm just going to click on the solid hatch, and right now it shows that this part in blue is going to be cut out, and the part that's in black here, the screen, is actually going to be shown, or what's going to be left of the metal. So I'm going to go ahead and erase that, and the thing that I want to show you is, let's actually start out with the P-lines first. So it'll actually help us out with the kerf lesson. So right now, whenever I click on these lines, they are all individual lines. So what has to happen whenever we send this to the plasma cutter is every time it sees an individual line, the tip of the plasma cutter drops down to the correct height, it goes across, it cuts that line out, it raises the tip, and then it drops back down and starts another line. And there's a couple different problems with that. The first problem is it takes a tremendous amount of time. The second problem with it is that tip won't start firing unless it has metal underneath it. So whenever you cut across here and you get to this point, you just blew away the metal in that corner. So whenever it drops down again to start cutting here, there's no metal for it to start with. There's going to be a little bit, and it might work, but it's not going to work well, and usually you're going to have a part that doesn't end up cutting out everything that you want cut out. So what we can do is we can make these into P-lines, and a P-line is basically, it can be a lot of different segments of lines all joined together into one line. So to do this, I use the pedit command. It's P-E-D-I-T. And whenever I do the pedit command, my first is I can select the polyline, or I can choose multiple. I'm going to choose multiple. So I'm just going to select all these objects right here. I'm going to hit enter to let it know that I'm done selecting objects, and it asks me, do you want to convert these lines into polylines? Yes, I do. Now what it did is it created a bunch of different polyline segments. So the next thing I have to do is I have to actually join those polylines together into one. So I click the join option, and whenever I go through and do this, it asks me to enter fuzz distance. So the fuzz distance is basically, if there's like a little tiny gap and I have a distance of like 0.125 and the gap is less than 0.125, it'll automatically fill in those gaps for me. I'm going to leave it at 0 because everything should be touching exactly. If I hit enter, enter again, and it tells me 24 segments added to 2 different polylines. So in here there's 2 different polylines. There's going to be the outer one, and I can click on that and it all highlights, and then there's the inner one. So now whenever you send this file to the plasma cutter, it's going to drop down, it's going to start the cut, and it's just going to continuously move around here until everything has been cut out. Okay, the next thing is kerf. So whenever we're talking about kerf, basically what's happening is whenever you're cutting this metal with the plasma cutter, you're losing part of the metal. So depending on the tips, depending on the material thickness, there's different kerfs. So we're going to look at basically an 1/8 inch kerf just to get an idea of what it is and how it works and how you can use it in your design. So basically what I'm saying is I'm going to take away every line that I cut. I'm going to take away an 1/8 inch of the metal, and I'm going to be left with a hole that's an 1/8 inch thick. That's probably a little bit wide, but at least it'll show us what we're working with. So I'm going to try something. I'm going to try using my offset command to identify where the kerf is. And I have these options down here. So right now this layer is probably like a layer 0 or something. I'm going to click layer, and let's see if I can change this to B, which is a blue layer. Or let's pick current. That'll set it to this blue. Alright, after that's set, so now anything that I offset is going to be on the layer B, the current layer. So I'm going to pick an offset distance. So I want to use an offset distance of 1/2 of an 1/8, so I can offset on each side of the line. So 1/2 of an 1/8 is a 1/16, or 0.0625 in decimal form. So that's my offset distance. And now it asks me to select the object to offset. So I'm going to try this. I'm going to pick this line, and I'm going to offset inward, and I'm going to offset outward. And I'm going to do the same thing for the outside line. So basically what's going on here, whenever you look at this object now, if I removed, or if I just turned off, use my layoff command, and I turned my white layer off, now the part that's going to be left is in here. And it's really hard to see that with all these different things going on. So I'm going to, again, use my hatch to kind of make it stand out. So now you can see the objects or the parts that are hatched in blue are going to be cut out of the metal, and the parts in black, that's what's going to be left. So the whole thing that you need to understand right here is the parts that are left are a lot smaller than what they were, because there's a lot of material removed. So you have to take that into consideration. So if you have two lines that are very, very close together, that are an 1/8 inch apart, whenever you actually cut those two lines out, you're not going to have any metal left. So you need to make sure that your lines are at least an 1/8 inch, probably better a 1/4 inch apart at the very least, so that you have at least an 1/8 inch of metal left whenever you're done cutting. And that's just a real quick, and we can actually figure out what the kerf is for different material thicknesses and different tips. I'm going to go ahead and use my lay on command, turn all my layers back on. And I'm just going to undo this to the point where I have everything back there. And I'm going to erase these lines that I used for kerf, so I can actually use these files for plasma cutting. So the next thing is looking at small details, small lines, small movements of the tip of the plasma cutter. Whenever I have something very small like this, and if I list this, it tells me that the radius of this is 0.0599 or 0.06. So that's pretty small. So if I would double that, my diameter is close to 0.12. So the diameter is around 1/8 of an inch. 1/8 of an inch isn't very big. Now you are going to get a little bit bigger object because of the kerf, but it's going to work hard to get all these small little lines. So if I went through and I had these triangles that I made, we'll say, and I expect it to do all this detail work like this, and I had a whole bunch of these little triangles all over the place, the plasma cutter really isn't the tool to do work like this. If you're going to do something that is this precise and this small, you're really going to have to move up to a laser, which is probably 10 times the cost. So what we need to do is not have all that detail. And we need to have smaller increments. So the next part of this is, let's say I had an object where, let's say I brought an image in and I was tracing the image, and I have all these, switch layers so we can see this, I have all these little tiny itty bitty, turn my snap off, all these little tiny things, lines, that makes up my object. I'm going to run into a lot of problems with that. So I need to have bigger segments. I need to have smoother objects. I can't expect the plasma to do this level of detail. And it's really just something that you have to play around with a little bit. All right, the last thing that we're going to do, really talk about, these are pretty much ready to go. So to get to the plasma cutter, it's really going to depend on the software that's running the plasma cutter, the controller. Back in the old days, a DXF file was the file that you pretty much had to use anytime that you were transferring information from AutoCAD to another program. Now we have a lot more options. You can do a lot will accept a DWG. So whenever I do save as, and my screen pops up, and I have Cube of Doom here, and get this box a little bit smaller so we can see it. So whenever I come in here to do a save as, I could save it as DWG and try that out, and if it works, then great. If I can't use that with my plasma cutter controller, then I'm going to have to come in here to files of type, and I could choose a DXF file. And I would say that's guaranteed to work. So after everything's done, and like I said, I'm going to start out with a DWG and see if that works. I know our plasma cutter does work for DWG. And I'm going to save this as, let's change the name of it, call it something different. Complex parts for COD, the Cube of Doom, and I save it, and I'm going to put this on a flash drive and take it over to the plasma controller and load it into the plasma software.